Hi, I'm Jordan Barber, and as an add-on for the Seaperch rover, I built a 3-fingered claw. The claw has finger segments to allow it to better clamp down on and grip different objects. So here's a list of materials that you'll need. You'll need about 4 feet of PVC pipe, duct tape, a standard servo motor, a servo motor controller, a 9-volt battery, some servo wire, a spring, a very small nail, nylon string, about 3 feet of 1/4-inch polyurethane tubing, and epoxy glue. On the list of tools that you'll need a bandsaw, sandpaper, scissors. In building it, first let's talk about the motor. So the servo motor will need to be able to have a long cord to its controller. So what you do is you split the cord coming from the servo motor that's supposed to go to the controller, and you put the extension cord attached right there in the middle. So for the servo motor, now that you have the extension cord attached, this is right now attached to my claw, but before you do that, before you attach your claw, you just extend the wire to the controller, which also has the battery, 9-volt battery attached, and that allows you to control the motor. Now we need to build the PVC body. To do this, you need to cut PVC pipe pieces to fit around the motor with 2 notches and pieces that go on the ends. Then you need to build the fingers. Here you'll see the finger segments. There's 3 segments on each finger, making a total of 9 segments. You also need a 4th segment to be able to attach in between the finger and the body. The 9 finger segments are to be made with about a 22-degree angle on the inside edge of the fingers to allow the fingers to close right there on the inside, as shown in this figure. See how it closes as the servo motor is engaged? So it needs to have the inside half of the finger to be at that 22-degree angle. That way when the inside string is pulled tight, the fingers contract. So once the finger pieces are cut with a bandsaw, the tubing, the 1/4-inch tubing, is then strung, as seen here, on the inside of the tubes. The 9 pieces, the 9 PVC pieces that have these tubes strung on the inside and the inside outer edge, as seen here. So that will allow the string going to the spring, holding the fingers open, and the string going to the motor, which closes the fingers, to be strung there and held in place. So this is put on the inside and the outside of the finger joints with epoxy glue. And then you need to put the finger pieces together and glue a guiding string along the sides, right at the angles, the change in angle, as seen here. That will allow the fingers to stay lined up when they're pulled tight. So then you string the inside and the outside of the finger tubes, those 1/4-inch tubes, with some string. And this string is going to attach to the spring and to the servo motor. You'll have to put tie a 1/4-inch, a really small piece, maybe a 1/4-inch of that 1/4-inch tubing to the end of the string, so that it doesn't pull through that final finger, so it stays in place. So once you've done that, it acts as a stopper, so that when the string is pulled tight, it can pull those pieces together, whether it's contracting or expanding the fingers. So once you have all the fingers strung, then you can bunch up all the wires according to what they're doing. So if the wire is strung on the inside of the finger, then that goes to the servo motor, so pull those over to the side. If it's strung on the outside, it's going to be going to the spring to pull those fingers tight. So once you have the fingers strung, you need to attach the fingers to the frame to create the whole thing as seen in this figure. So you'll see here the entire thing is connected together with the servo motor right in the middle, and that can be done with screws. Just attach it. The screws should come with the servo motor. So now the tricky part comes: attaching the strings correctly to their independent systems. So it's going to take some calibration. So the first step is attaching the strings at a set length to the spring. So these strings, if you remember, they're going to be holding the fingers open. They're on the outside of the fingers. So we need to attach them to the spring to allow the spring that is attached to a nail here on the back of the frame to pull those fingers open. But the tricky part is it can't be too tight that it's hard to close the fingers. It just has to be tight enough to hold the fingers open. So once you get it to that set strength of tying it to the spring here, that it's easily closed but yet stays open, then you can attach the strings to the inside side of the wheel, the side of the wheel closest to the fingers. That way, once you attach them pretty tight on there, they are able to, once engaged, pull the fingers closed. So the applying principle here is the torque necessary to pull these fingers closed. See, torque is force times distance. So it's the force that's needed to pull the fingers closed, applied by this wheel at a distance away from the center of the wheel, and that's the amount of torque this wheel will have to pull it. So the motor can only apply a certain amount of torque. They have torque specifications for it. So if it can't overcome this spring, there's only two things we can do. Either lower the distance or lower the force needed. So to lower the force needed, we have to loosen the strings attached to the spring. But if that is needed to hold the fingers open, we've gotten as close as we can to not opening our fingers, then we have to close the distance and have the applied distance of this force needed to close them at a lower distance from the center of this wheel to allow that torque to be smaller. And with a small enough torque, this little motor can handle closing these fingers. After everything's perfect, this baby really does work. It's actually really fun. So I hope you can do it too. And if you lose your hand, it could be very helpful.